When it comes to graphing different functions, one graph that you need to understand is the cubic graph. That's when it has an exponent of 3. Now what I'm going to do is on the TI-83, I want to show you just what that looks like in general, an x to the third power. You ready? This is the general graph. Just kind of looks almost like a sideways S, doesn't it? Okay? That's the general graph. Now we're going to you should know some rules about stretching and compressing. Now, let's talk about this 1/2 out in front. You guys remember that the 1/2 is going to vertically compress it, right? So you see my picture? That's going to look a little shorter. Let's make an XY chart when it comes to graphing these things. Let's go ahead and just pick some basic numbers, -2, -1, 0, 1, and 2. And let's plug those numbers in. 1/2 times -2 to the third power. 1/2 times -1 to the third power. 1/2 times 0 to the third power. 1/2 times 1 to the third power. And 1/2 times 2 to the third power. Let's plug all those in. -2 cubed is -8 times 1/2 is -4. -1 cubed is -1 times 1/2 is -1/2. This is 0, and then these are just positive of what's above. Now let's plot our points. -2, -4. Left 2, down 4. There's my first dot. -1, down 1/2. There's my second dot. 0, 0 is right in the middle. Over 1 up 1/2, and over 2 up 4. You can kind of see how it really does look like this example on my calculator. So we're going to try to keep that general shape and go through all of our dots. By the way, the one on my calculator, you should remember that's called your parent function. And that's a nice graph. Now it asks us to talk about the graph. It asks us to talk about the end behavior. So let's do that, the end behavior. You should notice on this graph, the end behavior is down up. Okay, the turning points. Well, something interesting about this graph is as I trace it, I would like you to kind of say to yourself, how many turns does it take? Okay, I want you to say increasing or decreasing. So as I move up, you should be saying increasing, 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 increasing. It has none. Just write none. There are no turning points. None. None at all. It's always increasing. Okay? So remember how we said that you take your exponent and you subtract 2? So you might think, okay, you might think on this one that it should be 3 minus 1 equals 2 turning points. You might think that, but this one, remember, this is just a most likely. In this particular example, it didn't happen, did it? So we notice that in this one, there are no turning points. And as I traced it, did you guys notice that it says it's always increasing? So when we talk about that, that's good enough for talking about, see how it says increasing and decreasing intervals? This one's always increasing. All right, let's move on to part B. This one's going to be a little different. If you want to rewrite it in standard form, it would be -x cubed plus 3x squared. Okay, again, you might think to yourself, that this one is going to have maybe 2 turning points. Let's check it out. I'm going to pick my normal values, XY chart. -2, -1, 0, 1, and 2. I'm going to plug them in. So this is going to be a -2 cubed plus 3 times -2. Be careful with all those negatives. This will be a -1 cubed plus 3 times -1. This will be a -0 cubed plus 3 times 0. This will be a -1 cubed plus 3 times 1. This will be a negative 2 cubed plus 3 times 2. Plug all those in here. You get a positive 8 minus 6 is 2. Here you get a positive 1 minus 3 is negative 2. 0 and 0. Negative 1 and 3. Negative 8 and positive 6. Let's plot those points. Negative 2, 2. Negative 1, negative 2. Notice this one's taken a very different shape already. 0, 0, and 1, 2, and 2, negative 2. Look at these funny graphs. They almost look like an X, don't they? Well, we should understand the end behavior. Okay, we learned about the end behavior. The end behavior, all right, we have a negative and we have an odd. So if you wanted to, you could just go backwards and you could say a negative and an odd is up and down. And look at our graph. I like to do the middle part first, it helps me. There you go, there's your up and down. Kind of neat how that helps us be able to graph it. Now this time, we do have some turning points, don't we? Our turning points occur here and here, where it changes directions. This time we actually have 2 of them. And they occur at negative 1, negative 2, and the other one occurs at positive 1, positive 2. Kind of neat. Now, if we talk about the increasing or decreasing, this is where it gets a little hard, okay? I want you to read the graph left to right. Can you notice that it decreases to start with? Let's talk about when it decreases. Are you looking? Ready? It decreases where my pen is. And then it stops decreasing because it starts to go back up. So it decreases from negative infinity to, what's the x value at this point? 1. And then it starts going back up, doesn't it? Alright, so that's increasing. It increases from where my pen is. Ready? Increase, 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 stop. So it increases from negative 1 to a positive 1 for x. And then it starts decreasing again. See how it's going back down? And that occurs from positive 1 for x to positive infinity for x. That'll probably be something we need to talk about a little more in class. We're going to do the got it's together in class, and I'm going to teach you how to help yourself use your calculator on this. And this is going to take a little bit longer, but I will teach you how to use your calculator. Now, this paragraph teaches you about example 4. Now I'm going to trust, I'm going to trust that you're going to read this paragraph and try to make some sense of it. I'm going to switch to the next page and I'm going to help you apply it. So if you could, pause the video, read it over, and then come back to me on example 4.